Welcome to The Tech Between Us, a podcast that takes a look at the past, present, and future of some of today's most influential technologies. Hi, I'm Raymond Yin, your host and Director of Technical Content at Mouser Electronics, a leading global distributor of semiconductors and electronic components. Today, let's set the Wayback Machine to 1987. I'm a young design engineer working at my first job at Texas Instruments right out of school. And in addition to really figuring out what it is we do as engineers, one of the most fascinating things about this job is watching our little mail robot wind its way across the cubicle, following a little painted line in the carpet. It would stop at our group admin's desk just long enough for her to unload our stack of printed magazines and letters before moving on to the next wing of the building. And, while it would occasionally lose its track and, stop and get stuck, I don't remember it ever actually hitting somebody or getting in another accident. So fast forward to today, 35 years, and autonomous mobile robots are no longer limited by that painted line in the carpet and now have more processing and communications capability than the actual system I was hired to work on back in 1987. And now, rather than delivering mail, these robots are primarily used in warehousing and logistics, where we've seen a huge uptick since the beginning of the pandemic nearly 3 years ago. In the warehouse, these AMR organize and stack pallets, they pick customer orders, and they do it all right alongside people in the warehouse. And they are becoming so pervasive and come in all shapes and sizes that one market report that I read said that autonomous mobile robots were the fastest growing market that they've ever researched. To dive into what sets an autonomous mobile robot apart from other robots and how they are being used in our daily lives, I have with me today Niamh Donnelly, co-founder and chief robotics officer at Akara Robotics in Dublin, Ireland. Hi, Neve. Welcome to The Tech Between Us.
Hi, Raymond. Thanks for having me on the show.
Outstanding. Hey, real quick, can you introduce yourself and Akara for us?
Yeah. So my name's Niamh Donnelly. And I guess my background was originally in mechanical engineering. So I got my bachelor's degree in that. But towards the end of that, I kind of realized that software development was really my strong suit. So I got a job at a US tech company called Etsy on their engineering team. And I loved working there. I got lots of experience. But while I was working there, I kind of started to see all these advancements being made in AI and machine learning and robotics. And I really knew that, that was what I wanted to do. So I left my cushy job, went back to do my master's degree. So I got my master's in University College Dublin in AI and machine learning. Coming out of that, it was tough going back to college, but it was definitely worth it. And coming out of that, I kind of was working in data science, but I knew I wanted to work at a robotics startup. So I had seen what a group of roboticists at Trinity College Dublin were doing. So they were building robots and they were spinning out as a company called Akara in 2019. So I joined them as a co-founder and to lead the AI and machine learning development on their robots. So I guess they were starting out building a robot called Stevie the robot. So Stevie was a humanoid robot that was built to be deployed in nursing homes. And we had a lot of success with that. It actually ended up on the front cover of Time magazine in 2019. So yeah, it was really exciting. And then I guess COVID hit. So we kind of changed gears a bit because at Akara, we kind of saw what was happening in hospitals with cleaning and turnaround times for cleaning rooms were going up to like almost an hour with the manual cleaning that they were doing at the time. And we couldn't understand why robotics wasn't being used more. So we built a robot called Violet. And Violet is a UV disinfection robot. So Violet is deployed in a hospital room and moves around the hospital room autonomously, shining UV light on surfaces and killing bacteria. And in some cases, we've actually managed to reduce cleaning times in hospital rooms from an hour to just 15 minutes.
That's incredible. All autonomously working side by side with the nurses and other hospital personnel moving from room to room, huh?
Yeah, exactly. So the kind of idea behind Violet is that Violet can work safely alongside people. So we have AI on the robot to be able to detect humans in the room and to be able to avoid them. And while they're, preparing the room for the next patient, Violet can clean other sections of the room.
That's terrific. I'm sure that helped out a lot over the last couple of years for sure.
Yeah, definitely. Actually, cleaning in hospitals hasn't changed since the Spanish flu pandemic. So,
oh my gosh, was that 1918 or something?
Exactly.
That's
So
kind of scary.
we felt robotics were definitely needed in there.
I would say so. Long overdue.
Yeah.
So to begin with, we've been talking a little bit about autonomous mobile robots. Now, is there a specific industry definition or a set of features that designates a robot as autonomous and mobile, or is it just simply kind of a generic term that's being used these days?
Yeah, there is kind of like a broad industry definition. So I guess an autonomous mobile robot, or an AMR for short, is any machine that can automatically move around its environment and based on its feeds coming from its sensors, is able to move around without actually being controlled by a person or without explicit instructions to kind of follow a predefined path. So you've probably seen, robots that follow a painted line on the ground. That's not actually an AMR. An AMR actually has to take in sensor values and build up a representation of its environment and then use some algorithm to be able to build a path from point A to point B. So it's kind of a higher level of intelligence.
So there really, like you said, there is no particular set path. It doesn't have to go right at do a right turn at a specific place and a left turn. It could just determine based on where it is and where it needs to be, how to get there by itself.
Yeah, exactly. So it's kind of a higher level of autonomy. So usually you'll have what are called planner algorithms. So you'll have a global planner, and the global planner will have kind of a static map of the room that you've mapped out before. And then you will give it its starting point and you'll tell it to go to another point and it will compute a path using some algorithm that you've chosen. And then you'll also have what's called a local planner. So the local planner kind of plans around dynamic obstacles that are in the local vicinity, so that are right beside the robot. So it can kind of move around them locally with the local planner and then still be on the global path to the endpoint.
So I'm a gamer, and so it sounds like what you're describing is, we always have a world map where you have, the overall layout of, obviously in games, the entire world, but, for a robot, wherever it needs to be working. And then you have a local map that has all the individual, little pieces, people, desks, things like that it's got to take into consideration.
Yeah, exactly. And, it uses sensors to build up these maps. So usually you'll have, and these can differ between any type of robots, but usually the standard is you have a LiDAR. So a LiDAR is a time of flight sensor. So it sends out a beam of light and it sees how long it takes to reflect back to the robot. And then that estimates the distance that object is away. And usually the LiDAR is used for what's called localization. So that localization is how the robot can tell exactly where it is. So it uses what it's reading from the LiDARs, compares it to the map that you've given it, and kind of guesstimates where exactly it is. And there's loads of different types. Like on Violet, we have a 2D LiDAR, so it just has an XY coordinate. But you can kind of have a 3D LiDAR, so that gives it, an XYZ coordinate, so you can see what's above and below the robot and kind of have a more detailed map. And then, there's loads of other different types of sensors. So you can have 3D stereo depth cameras. They kind of give you a more granular view of what's going on and would be more likely used for the local cost maps. So on Violet, we use Intel RealSense cameras. So that tells Violet what exactly is in its immediate vicinity so it can move around it easily.
So the robot has to take all these sensors, actually kind of like an autonomous vehicle, the self-driving cars. You got LiDAR, you've got cameras, you've got other, probably, temp sensors, things like that. And it's got to, from all that, it's got to create a map, a visualization of where it is and where it needs to go. So there's probably, quite a bit of processing power on Violet.
Yeah, so Violet definitely needs a lot of processing power. And at Akara, we really quickly realized that, our Intel NUC or computer that's on the robot mightn't be able to manage all these different algorithms. So we looked at what's called AI at the edge. So this kind of idea that you can run these heavy algorithms on small embedded hardware devices. So an example of that is the Intel Movidius compute stick, or you can use an NVIDIA Jetson or a Google Coral. So you don't have to rely on forking out for a super powerful onboard computer or worry about draining the robot's battery. They're also super cheap. A compute stick, I think, is about €100. And last year, Akara were actually part of the Intel Movidius Accelerator program in Dublin. And we were able to convert all of our algorithms into OpenVINO, which is the software that runs on the Movidius stick. And we were able to go from running all of our algorithms at 15 frames per second to over 30. So it really made a huge difference just kind of moving to this.
Yeah, so just changing platforms doubled your performance.
Yeah, exactly. It was really great.
Brad connectors and cable assemblies from Molex are designed to simplify the design, installation, and maintenance processes in the most demanding industrial automation applications and provide one convenient solution for numerous interconnect and communication requirements. Learn more by visiting mauser.com/Molex.
From a machine learning standpoint, we've talked about all the mapping algorithms, and it sounds like you're doing the a lot of the image detection and recognition in dedicated hardware. What other sorts of algorithms, what other sorts of things are you asking Violet to do, just in its daily work?
Yeah, so I guess one of the things that kind of makes Violet different from other UV disinfection robots is that Violet can work alongside people. So Violet has 360-degree view cameras and is able to onboard run person detection algorithms to be able to detect whereabouts in the room a person is, and can kind of move its light shield away from the person because UV light can be harmful to eyes and skin, and is able to kind of update its navigation to move away from the person. Also, we kind of realised that, we would love to have feedback in terms of how clean a room is or how much UV dose a certain surface has, and then maybe update the navigation based on that. So the next time Violet cleans, it knows where it spent most time the previous clean, so can kind of update its path. Yeah, so that's something that's kind of new technology we're working on at the moment. And then, that will all feed into the navigation system. So it's not just kind of one navigation algorithm, it's multiple algorithms. Kind of, you have the global planner, the local planner, you have the person detection feeding into it. And we hope to kind of have this UV dose readings, updating and improving the path over time. So we kind of have this idea of data-driven cleaning. And I guess that's something that, kind of really excites me, the fact that it's, getting better over time and the robot's kind of learning and improving things.
Yeah, that really is interesting because, we expect robots to basically, do the same thing over and over again. Obviously, from traditional robotics, that is what they do. They take over a lot of the repetitive tasks that they're expected to do the same thing over and over, whereas you're asking Violet to actually learn based on the previous cleaning and do things differently each time, potentially.
Yeah. And it's really interesting how, different robots and different industries have different problems they want to solve. So, we're looking at making cleaning better and improving cleaning, whereas you look at Amazon and they have these giant warehouses, and what their problem is more focused on is one warehouse might have 8,000 robots, but they build their own warehouse. They can make the lanes as big as they want. They can, so their issue isn't really navigating from point A to point B. It's actually having all these 8,000 robots not crashing into each other. It's just such a different problem because they can have control over actually the navigation algorithm, but, there's so many of them moving. They kind of have, and it's not my area of expertise, but they would put a lot of focus on managing kind of swarm and like multi-agent algorithms. And I've kind of been reading about them. They have this kind of cloud infrastructure, and they kind of work like an air traffic control, where they have the coordinates of the route of every robot, and they can kind of have this mass delivery robots kind of moving all around at once and never crashing into each other. I'd love to actually see it.
Yeah, that really is interesting that, we've got, AMRs, primarily in warehousing and logistics, but obviously we're seeing them in other industries, a lot of places, healthcare, hospitality, things like that, where the definition of autonomy and mobility is completely different from scenario to scenario.
Yeah, exactly. And like different focuses are needed for the different applications. So if you have a service robot, or even one that's more like Violet that the general public will be able to use, like the UI and the user experience is a lot more important. I think it's being kind of pushed with autonomous cars, and like now every car nearly has like a UI or some kind of interface that you interact with it. Like I don't think I could park anymore. I don't think I could park my car unless I had that reverse camera on the car's UI. But the same goes for robotics. Like now the general public are kind of starting to interact with them more. Like you'll see the service robots in restaurants bringing your food, and people are starting to use them more. So a lot of effort now and a lot of focus has gone into kind of UI design. And we do a lot of work with kind of human-robot interaction, or HRI. So, what is the best way that someone can tell Violet to stop cleaning, or, start a clean, or kind of get information from Violet? And it's kind of a really hard thing to kind of decide. So we first started off with a robot UI that, as engineers, we thought was brilliant and really easy to understand, and brought it to the user, and they were just like, what is this? I don't know what's going on. Why is there a Linux kernel here? But yeah, it kind of opened our eyes that, we really need to make this easy to use, or people won't use it and it won't get adopted. Like one of the biggest reasons a technology won't get adopted is because people find it too difficult to use.
Right. Yeah, absolutely. And that's that's even, going beyond simple safety and simply making sure that the robot doesn't run into anybody. This is now, how do you make the robot listen to somebody? Yeah,
exactly. And like speech interfaces are becoming a big thing. There's kind of a controversy over whether that is the best way to go. Should we just stick with using a screen UI and actually having someone go over and move it? Or, should we move to voice control? The natural language processing algorithms have like really advanced in the past 5 to 10 years, that it's becoming easier to implement them. There's a lot of open source libraries that you can use. But I guess one of our robots, so we don't just have a UV disinfection robot. There's kind of some other things in the background that we're working on, and one of the robots makes a bit of noise, and we were kind of testing a speech interface, and when the robot was on, it couldn't actually pick anything up because it was so noisy near the microphone that you couldn't hear it. So yeah, it's kind of, you think something will work and then you try it in the real life and it doesn't.
And that actually brings up another point is, when we were, last year during this podcast, we talked to a professor, Natar Jaran, at one of our local universities here. And he mentioned that, you can train and plan and whatnot, all your algorithms and your machine learning. And then when you actually get it out there, you really have to it undergoes a whole nother change in practical use.
Yeah, I 100% agree with that. And, I was actually nearly taken aback when I first got into robotics that people didn't just build things in simulation and then let them go into the wild and they worked perfectly. It definitely, we've definitely had cases where everything works really well in the lab, and then you bring it into the real world environment, like a hospital, and things don't go to plan. One area in particular that I've noticed that happens a lot is kind of around the sensor suite. So, like if you have a LiDAR on your robot, they're really affected by kind of the lighting conditions, and, they can't detect surfaces like glass. And it's kind of hard to replicate the environment it will be in. Or a 3D stereo camera can sometimes have these kind of salt and pepper noise and in certain lighting. So kind of knowing the limitations of your sensors in certain environments and, being able to compensate for that. So say if the LiDAR isn't good in a certain situation, then have kind of a backup sensor of the 3D stereo camera, or by using like sensor software filters. So, being able to make sure your readings are as accurate as possible can really kind of give you a jump ahead around those potential issues. You just never know what's going to happen, but you can kind of preempt a little bit in terms of sensors. But we also kind of had that issue with kind of some of the training we did with our models. So we were originally using kind of some pre-trained models for detecting people, but we found out that kind of during COVID, obviously everyone in the hospital was wearing kind of heavy PPE and, it looked a bit different. And, we had to actually go back and retrain the model and add in kind of, but yeah, so, you kind of forget that, okay, the training set that this model's trained on was probably even before COVID and definitely didn't have people in it with PPE. Like, it would pick them up sometimes, but then you kind of need to give it a little bit of help to be able to pick up on those things.
Right. So the models are actually so accurate they can tell the difference, or actually be confused by, somebody not wearing a face shield or versus somebody wearing a face shield and a heavy N95.
Yeah, exactly. They mightn't know that they're a person. Yeah.
Yeah, I figured, okay, you get the rough outline. Okay, we got body, and we person. Don't go that direction. But to get down to the level where the robot needs to distinguish between somebody with a face mask, somebody without a face mask, so on. That's really interesting.
There's a lot of pre-trained networks came out that were able to detect, if someone was wearing a face mask or not. So like, I think a lot of the community, that was probably something that was really needed to detect if someone's, being safe and wearing PPE. But there's a lot of pre-trained networks out there that people have already created that can actually do that.
The Python family of CMOS image sensors from onsemi combines flexibility in configuration and resolution with high speed and high sensitivity to address the needs of general-purpose industrial image sensing applications such as machine vision, inspection, and motion monitoring. For more information, visit mauser.com/onsemi.
So going back real quick to kind of to the safety, this topic of safety. We've talked a little bit about avoiding people. Obviously we don't want Violet to go crashing into somebody, nor do we want Violet to actually give somebody a tan with the UVC light. But are there other types of? I mean, since you're working so closely with people and people who are, like you just said, who are maybe not used to being around technology, are there other things that really that you guys have taken into consideration to be able to create that safe environment?
Yeah, so for Akara to sell a robot in Europe, we need to have what's called CE marking. So we need to make sure that Violet meets the machinery directive. And this requires us to perform a detailed risk assessment where we need to identify all the things that could go wrong. And then we need to look at how we could mitigate against each of these things. And a part of that, obviously, is the robot's safety system. And although we can do a lot with AI, we kind of can't rely just on software as a safety system. So there's, on Violet, there's kind of 3 levels of safety. So the first one is Violet's SOPs, so the standard operating procedure on how to use Violet. So we have kind of safe and repeatable instructions on how the operators can actually use the robot, and only trained operators can use and control the robot. And we run a lot of kind of staff training to make sure that they are using it up to code. And then there's like additional safety procedures that the operators will have to use. So UV radiation is regulated, and there's a threshold of over an 8-hour period of how much you can have shining on you or be near. And so our safety procedures do require that safety gear is worn to protect skin and eyes. But we also have these kind of wearable sensors. So you just wear the sensor and it measures the UV dose. So, if you are getting any UV dose, it will kind of beep and you move back away. And then only then kind of does the actual like software kick in after. So we kind of have the computer vision for safety. So being able to detect if a person is in the room, you can have it on a certain setting so that it will just turn off the light if there's a person in the room. Or, we have then as well to make sure the robot doesn't, go near a person or have a crash. You have the navigation system. You have the software that stops the robot before it hits an object. But then we also have like a safety rated LiDAR, which automatically is connected to the motor controller that will stop the robot as if it's within a certain distance of an object. And then you kind of have the last line of defense, which is a bumper on the robot, kind of like the Roomba uses, which is you don't want to go that far, but it's like
we
all
hope
else
not.
fails. Yeah, exactly.
But
yeah,
we get the last
like,
panic button.
Exactly, yeah. And then there also is like a big red button emergency stop on the robot.
Oh, there is really one, okay.
Yeah, so that's part of like the CE marking, and you have to have all these things. So it's really kind of like a hurdle effect. So there's so many different layers of safety that it's almost impossible that it will, that an accident will break through all of them. So it's not just one single thing. It's kind of a multitude of safety procedures that protect it.
Just different shells of safety. Some of them based on software, some of them based on hardware, such that so there's really no way for Violet ever to really have an accident. So you guys have developed Violet. I know you guys are in some deployments, and when you go from a single Violet, a single hospital to thousands of them, does that change the way you guys approach the robot or the service or system in general?
So yeah, that's something that we're just beginning to look into now. So we're still at kind of the early deployment stage, but now our early deployments, we're starting to add robots to a hospital. So the plan, I guess, is to have maybe around 10 to 20 robots per hospital. And it wouldn't be like kind of in Amazon warehouses where it's like a hive mentality. They won't be working side by side. They'll be largely independent. But we really do need to manage and maintain each robot remotely so that, if something goes wrong or, we can kind of anticipate their usage, or maybe one robot in one area is being used a lot more, and we could maybe kind of add another robot in that area. So what we're working on now is kind of building out a cloud infrastructure so that we can manage our fleet. And kind of there's a few reasons for this. So we would really like one of the killers for robotics companies is having to call out all the time for maintenance call outs. When you think about it, if you have 10 robots in 10 different facilities and you have to send people out to them all the time, it would be disastrous. Yeah. So what we hope we can do is kind of predict how the robots are being used, so how often they're being used, and try predict kind of maintenance call outs in advance so we can kind of do an upgrade of all the robots that need to be done at one time. And we really feel that kind of as we grow the number of robots we have into more locations, that this will be a lifesaver. So not only is the kind of infrastructure we're building for logging to be able to tell, how many days the robot's been cleaning or its battery levels or logging any errors, but to actually kind of estimate its usage and be able to anticipate when, an upgrade might be needed. And yeah, so we kind of Akara works as, you might have heard that term, robots as a service.
Yeah, actually, I was going to ask you about that. It really sounds like that's the model that you guys are going with. And as well as, I know, that is kind of, the as a service thing is really, it seems like, a lot of industries are heading that direction.
Yeah, 100%. It makes so much more sense for both the consumer and the people building the robots, because the consumers get kind of free upgrades. If there's a new feature, like say you buy a robot and it doesn't have a speech interface, and then the company that sold it to you start building a speech interface. If you use robots as a service, you can just kind of add that onto your robot and then have it. Whereas if you just buy it straight out, you kind of have a depreciated hardware from the day you buy it. So it's really beneficial. And there's kind of also that other aspect of being able to scale. So particularly for us, say, for example, a hospital might have a busy season like flu season or in the winter where they kind of need more robots at a time and need to be able to kind of have rooms cleaner quicker. They can kind of scale up the number of robots they have for the winter season and then kind of scale back down. So it's really beneficial to hospitals, and they have a greater level of support, and we can kind of help on working to improve the robots over time, and continue working with hospitals. So it's kind of a best of both worlds for each the customer and the people building the robots.
So robotics as a service, once again, you've been hearing about, everything as a service, and it sounds like it does make a lot of sense for, especially for big expensive pieces of hardware.
Yeah, exactly. Like you don't want to have something that doesn't work in a few years, or that not even doesn't work, but just doesn't improve along with the technology that's improving.
And, and you had mentioned, and it sounds like, once again, you found another use for artificial intelligence and machine learning in, not only guiding the robot and, making sure it's safe and gets to where it needs to go, but now we're into, predictive maintenance algorithms for when you take the robot offline and do maintenance or whatever. So, AI is just, machine learning has just been layered into, into every aspect of these autonomous mobile robots.
Yeah, exactly. Like once you kind of have the infrastructure set up so that you can kind of get that data, there's so many different ways you can use it, even to predicting like what rooms need to be cleaned more, or other improvements that can be made. It's all kind of it is, I know it's such a cliche, but it is kind of about collecting the data to improve the product. I hate that I use that phrase.
Oh, but it is absolutely true. And I think even for you, and I bet your customers would be really interested in seeing some of that data in terms of, okay, what levels of disinfecting are required for different areas of the hospital.
Yeah. So as I kind of touched on before, it's not just a UV disinfection robot we're building. We're trying to build and improve the way hospitals are run and their kind of efficiency of cleaning and facilities management in hospitals. So, a cleaner would typically go into a room and fill out a sheet of paper to mark off what they've cleaned. Whereas, it would be really simple to be able to digitize that and then also have the robot feed into that. And, a lot of facilities spend so much time in hospitals just looking through kind of cleaning schedules and what's been done. It takes a lot of staff resources and people's time, and hospitals are already overrun as it is. So kind of having like digitizing some of the processes and having robots that are kind of recording data to be able to feed back to facilities management managers is really used
Yeah, I can imagine. Yeah, I mean, transposing a physical piece of paper, information on a physical piece of paper, to transcribing it, whatnot, as opposed to automatically creating your database of times and places and levels and just. Yeah, that's an incredible increase in efficiency.
Yeah, it's just all that data kind of goes to waste if it's not recorded, and infection outbreaks in hospitals are still kind of even without COVID, were always such a big problem. So just having records of how clean the hospital floor is really helpful. So,
we've kind of been talking about kind of, where we are today with these autonomous mobile robots, and, they're, starting to show up everywhere. Obviously, warehousing and logistics, healthcare, all these different places. As a roboticist, where do you see it all going? In terms of both the machine learning side as well as possibly, the hardware and use case.
Yeah, I guess it's funny because the hardware area isn't my area of expertise, but it is one that I find interesting for the future. So kind of how we think about the embodiments of different robots and how they'll change. So like right now we can kind of see it's mostly wheeled AMRs, but drone delivery and drones and kind of we see like Boston Dynamics building non-wheeled robots, and I think it's really interesting. To be
I
able
love
to
the
see
dancing robots.
Yes, exactly. I know they're not. We don't know what they're doing yet, but I think it's really going to be interesting to see how they evolve, and then also how kind of the designs of buildings that we build today are going to change to accommodate for AMRs. So like hospitals are actually great places for mobile robots, because when you think about it, they're really big hallways, the doors always open, they have to move hospital beds around all the time. It's actually kind of, some of the rooms can be cluttered, but largely compared to other places, like we were originally working in nursing homes, and that was difficult to have a mobile robot move around. But I can kind of see how hospitals are being built for moving kind of machinery around and moving things around. I think it's interesting to see how our kind of day-to-day lives and how designing buildings, will that change to kind of accommodate for mobile robots, or will there still be problems in trying to get wheeled robots upstairs?
Right. Yeah, they're actually, the robots, the use of the robots is actually potentially going to drive changes within what we do, rather than trying to adapt a robot to our environment.
Yeah, exactly. I think it kind of takes a bit of both. Like we kind of have to build things to accommodate for mobile robots, like even things like having bad internet in like hospitals are almost in some places like Faraday cages, like trying to get an internet connection, and that's part of the reason it's really going to be difficult. So like that was one of the reasons we kind of moved to AI at the edge, where we could run all our algorithms on board, so we didn't have to rely on that. But hopefully in the coming years we'll kind of see that we need to kind of change how we build facilities to be able to accommodate for mobile robots.
And there you have it. A brief look at how autonomous mobile robots are going from a collection of sensors and motors and processors to being an integral part of what we do every day. Neve, I want to thank you for being our guest today and sharing your insight and your experience with these robots.
Thanks so much for having me on the show. It was really great speaking to you.
Yep, absolutely. Great speaking to you as well. We hope you've enjoyed this episode of The Tech Between Us. Remember, this podcast is just one part of our original and ongoing content series, Empowering Innovation Together. You can find videos, articles, and more on autonomous mobile robots at mauser.com/empowering-innovation.